That's fine.
Got
We're
it.
good.
Says work duties, so.
Got it.
I'm not
Some
arguing.
digits
I'm
are-
not arguing your logic or thinking you're wrong because
Got it.
I just not,
So-
not slapping to those big ass heads.
So, do we get a drawing of that?
What?
Do we get a drawing, like in the problems? You're describing how the ends are, right?
Mm-hmm.
Does it come with like a,
They don't typically. If you would like me to draw the end conditions for you,
I'm just
we
trying to
can.
figure out like what the rotation free
So,
is the triangle with the dot,
yep.
or the circle.
So you've got your code down here too.
It'll be easier
Right down.
Okay.
figure it out.
Yeah.
Once you have it in front of you.
Yep.
Laterally restrained. Laterally restrained mean translation?
Translation. Yep.
So one. I'm thinking.
Okay. So, at the top and bottom, in both directions, we're translation restrained, but rotation free. Okay? So, pin connections, right? Yes. So, K value of 1.0.
With respect to the x-axis.
With respect to the x-axis, we're unbraced in that full length. Okay? With respect to the y-axis, we're unbraced between the horizontal decks, flooring, whatever it is. Okay? L1 equals 30 feet. L2 equals 18 feet. Okay? We'll use a W12 by 53. Okay, so our
Provides bracing and y. So it's unbraced between the bracing.
correct. Yep. Yep, that's literally what your unbraced length is.
I got you.
The distance between your bracing. Yep. Okay, so let's look at our x-axis. What's K times L over R?
I'm still trying to.
Yep. Times 30, and then we need to convert. Right? Over 5.23. Okay.
Okay. So 145 for. Oh, 5.23.
How much? Yeah,
I
5.23.
did, yeah, I did the wrong X.
69.
Okay? Yeah, what'd you say? 35.3, right? So it gives us an unfactored compressive load of 35.3 KSI. What about around about the y-axis? Do we change anything in the numerator?
Yeah.
Yeah.
What do you change?
16 or 18, 30 to 18.
We change our unbraced length from 30 feet to 18 feet, right? Yep.
216 inches.
And then change it to 2.48.
And then, yep. Then we have to use our R sub y, right?
I don't know why.
R sub y.
I don't know why.
Because now we're looking about the y-axis, right? So we're no longer
R sub y
interested.
is the.
How is this rotating? We're no longer looking at how is it rotating this way. We want to know how is it rotating this way. Okay?
87. Which is 28.7. KSI.
28.7 KSI. Yep.
So is this ultimately going to have two answers?
Nope.
Or do we? Okay.
Nope. Because we still need to figure out what that maximum factored load is, right?
Yeah. So we got this slender or the critical, the F sub C.
Yep.
So do you?
So
'Cause
now
we have two. We're figuring for two different things, the X and the Y. Do we add them together on
Nope.
the next equation?
Nope. Okay, so, and this is a good question. Think about what is it that we want to
We're gonna
determine?
go with the minimum.
Why do you want to use the minimum?
Because it'll fail first, or
Yep.
you get a
Yep.
buckle or whatever.
That's going to give us our do not exceed value, right?
Yeah, okay.
So what Rush is asking is, so what do we do with these numbers? Remember, we're applying the same load throughout that building, right? The load does not care how resistance to buckling occurs. Because of our different bracing and because of how our steel is set into place, it's going to buckle differently in both of these axes. Okay? One of these dimensions will fail before the other. That is what we're trying to figure out.
Put them in the P sub U equation.
Yep.
Yeah. 0.9. That's 28.7.
But now think about this. Does this change based on our orientation?
Still y.
Yeah.
Yeah.
Does
We-
this change?
No.
So the only thing that's changing is this.
Yeah.
And yes, Logan, as you said, this is going to give you a lower number, right? It's a lower value. When you multiply a smaller number by two things that are the same, the smaller number will remain the smaller number.
We want it lower number.
Yeah,
right?
it's,
Yes.
that's your limit. 403 kips.
Okay? So yes, once you get to here, you do not have to take this one further. You're just doing extra math. Okay? Typically speaking, an employer won't pay you to do extra math.
Here's the thing though.
No, but they will pay overtime.
If you're doing a bunch of extra math, John, they'll move you to salary faster.
I say we know the X and the Y radius, but I suppose it does matter on the L1, L2. Because I was like, why don't we just figure out for the Y? Because we know that's,
If L2
but
is
if
like
L2 is longer,
twice as long
Yeah.
as
then
Yes.
they'll switch it up.
Yeah, yeah.
Okay.
And I off the top of my head, I'm not enough of a structural engineer to be able to throw out, hey, for this type of shape, here's where it has to be, where it's going to throw you
Yeah,
off.
well, I mean, if you look at this
But-
one, L1's larger and RX is larger, so you could kind of just figure, well, get rid of it.
Yep.
You know what I mean?
Yep.
What's the final answer?
403 kips? 403 kips?
Yeah, it ends up being, yeah,
It's
403
like
kips.
402,
Yep.
depending on where you're on. Alright. So, I'm glad we did that one.
Okay?
I It's not so bad.
Can you handle a couple of these problems?
Yes.
Mentally? Probably. Emotionally?
Not emotionally?
Not emotionally.
Well,
We're tightening the noose around our trusses in the port.
Yeah, I think we should kick out the report part of that.
I was about to grind it anyway and just wait for the rest of the data. I was gonna make a little bit longer because the design, $75 an hour for design, and I threw that in CAD in 10 minutes. So I'm gonna include all the,
I think design's still building.
yeah, because when we were out there doing all the lines and stuff, like mocking it up, I'm gonna throw a whole hour into it.
okay, so for your homework, 10.3 A through D on page 341. Okay? So that'll be due a week from today.
Cool.
Seem reasonable?
Yeah.
That's
Seem
posted,
achievable?
those numbers are posted for the problems.
I'll get them posted here yet. I haven't posted it.
It seems strange that.
What do you mean, that?
X is this way and Y is this
No,
way.
oh,
I don't know why they do that either.
Right there, 10.3. Assume
Oh.
A
So, I
992.
mean, oh, you mean in the structure?
Yeah.
That's only because of how the beam is oriented, right? If we rotate that beam 90 degrees, then your X would be in this direction.
Sure.
Yep, it's related to, so what Kurt was saying is, he just feels that that's weird that we choose that coordinate geometry. But remember that the coordinate geometry is based on the shape of the steel itself, not on where we're placing it in the structure. If that makes sense.
Yeah. And is
So-
the Y smaller because it's easier to bend it in that way?
Yes.
Yes, you have smaller radius.
Yep.
That steel size, the W by 53,
W
12 by
53.
53, that is in a chart somewhere, or that'll be given in the, okay.
Yep, yeah, so the question is, where is this information?
Oh, that's what gives us that.
Yep.
Okay.
Yep. Once you remember that the largest portion of the steel manual is pages upon pages upon pages of angles, of flanges, of wide flanges, of pipe, all these different shapes, and then all of these computational values. Their radius of gyration, their moment of inertia, their blah, blah, blah.
So your L2s are always between the beams, it's not center to side? So if you got a, you know what I mean?
The beams. Yes, because the bracing stops
So
at the end of the bracing member. So Steve's question is,
And it goes all the way to the end of your flange.
is L2 really this distance, or is L2 this distance? Right?
basically, yeah.
And, assuming that I drew those on set, right? We take them between the bracing member, because as you're dealing in the member itself, the member is where the bracing is occurring, okay? So yeah, if you have any sort of physical member that's there providing bracing, go to the end of that dimension before you take your measurement. So now, from a constructability standpoint, we may not be telling people the unbraced length to put the thing together, right? We're probably telling them the center on center, so that they know how to locate everything. Yep. Yep. Yeah, unfortunately, we won't be able to get into things like connections and torsion this semester. That's a whole other bag of fun. Okay?
Materials one
Like an
time.
idiot.
Okay, so I'll get that posted for you. Tuesday, you can get back into the lab, and then next Thursday, we'll finish up with wood. Okay?